Hey everyone, today we're at the lab and we are going to be doing a bit of an experiment on a power generation tactic which I have devised, as well as an accompanying script which should hopefully mean you can distribute your power generation. Well, what do I mean by distribute your power generation? Normally, you're going to have some sort of a source of power in a lot of bases. This will be your large batteries, wherever you have those. Behind that, you're going to be generating power somehow. So whether you have wind turbines, windmills, solar panels, generators, whatever is going to be creating your power. Now, generally speaking, shoving those anywhere along your circuit is a bad idea. Now, the other component that you're going to have, in addition to your power generators and your storage, is your load. So in this case, I am simulating a typical station load setup where we've got a couple of different APCs representing different rooms with different loads behind them. This one I've got hooked up just to my airlock, just so there's something hooked up, but these are mostly just to demonstrate that this is the main circuit. Behind this APC, I have a transformer which feeds this whole circuit right here, and that is for purposes of the demonstration. Now over here I've got this secondary battery, and this is to demonstrate a load that we are injecting partway through our base. So this is downstream from the primary load, and it's behind this transformer. Now, you're probably already starting to get an idea of what these two transformers are for intuitively, but I'll get to that. The problem is, let's say we have some sort of power generation that is in a later part of your base, and it may or may not be sufficient for the load that you have at that side of the base. Let's say that I have my H2O generation, right? So I'm making water that creates a lot of heat, and then I'm trying to turn that heat with a Stirling generator into more power. That's actually the scenario that made me start thinking about this. Well, the problem is, this was really far away from my power generation, so normally you'd have to run a massive amount of cable, heavy cable even maybe, all the way back to your source batteries with some sort of a secondary circuit that follows around and doesn't intermingle with any of the wiring of your first circuit or goes around it somehow. It's a big pain. It costs a lot of materials. In this circumstance, what I want to do is power my, in the case I presented, water generation, or actually my entire plant room or greenhouse setup, by this power when this power is available, and when it stops becoming available from the secondary source, in this case an RTG, just for demonstration purposes, then switch back to the main circuit power. Now, a couple of questions arise. What's that going to break? Are you going to be able to power the integrated circuit off of the same line that you're switching sources between without it breaking? Are you going to fry cables by having more than 5 kilowatts running through this line at any given moment at the time of the switchover? Well, I'm here to answer all of those questions, and they are very satisfactory. So, I've done some testing on the way that the Stationeers power switching works at a very fast, like single-tick perspective using this little setup, and I'm going to demonstrate that this method of power switching is completely safe, even to run critical components off of, which if for some reason even one tick of downtime would completely destroy your base, this should still be able to support that. Okay, first off, our test scenario. So we've got our main power, powered by an RTG, just so it's constant. We've got our secondary power, in this case also an RTG, so it's constant. I'm running all of this through a battery, which I'll switch on and off in order to control whether or not it is an element, or charging, or distributing. Over here, we've got our IC housing, and usually you would run this off of the same line that you're pulling your data from, which would be the load line for whatever circuit you're trying to power by these two power supplies. So in the example I gave, in your greenhouse, on your greenhouse circuit, you would have this IC. The reason I'm running it off an RTG is simply so that when I load this cable fully with this battery, this is only a load. The purpose of this battery, because batteries will pull as much as you feed them, is once I switch this on, it will start charging at the maximum rate this transformer allows, or this transformer allows, whichever is active, of 5 kilowatts. So the maximum of a standard cable. So that's going to completely max out the line. The battery is going to get priority, so all other devices are going to shut off, or they normally would. So the reason I am powering this IC off of an RTG is simply so that that does not happen. So that I can perform the demonstration even with the power completely drawn from this line all to the battery. So this is only for demonstration purposes. Normally you would run this off the same circuit that it's pulling from. So this is a very simple IC. We can go ahead and take a look at it. Let me just manually... okay, so what's happening here is it's trying to use the battery, but I've turned it off, and I have no handling for that in my code. All right, let's turn the battery on. And just for the purposes of making things easier for later parts of the demonstration, I'm going to take away the power generation so that it hangs at this level. Okay, so let's check out the IC. It's really simple. It is just looking at the battery charge ratio. And if it is under 10%, or if it's over 10%, it will use this battery. And if it's under 10%, it will use the transformer that's bringing in our mains power. Okay? Super simple. Okay. Let's get to the testing. So with this setup, as soon as that gets too low, we are going to see the circuit flip over to the mains power transformer. I also have this cable analyzer where you can see that with both of these on, we got 225 watts, 25 for the LED, and 200 for the computer. And if you watch that, at the moment of the flip over, that is going to stay at 225 watts. That's not going to fluctuate. You'll also see the light won't turn on, and if you watch the computer won't turn off. So if we just wait here momentarily, we can demonstrate that that is, in fact, the case. And boom, the switchover just happened. You see the light never turned out, and the cable analyzer never showed a load under 225 watts. That means there was not a single tick where the load was not being satisfied by the power supply, even though visually and audibly it seems like there's a delay when the transformer switch. So you can hear the click, and you can hear a moment before the transformer background audio kicks in, and you can even see a moment where this is switched on and green but not lit up, and yet all through that entire time the load remains powered. There is never a dip below where the potential is failing to meet the actual load. Alright, there's one more thing that I want to demonstrate before using the battery, so let me plug the RTG back in for a moment just so that this battery gets powered enough. And I'm going to pull it off, because that should be plenty. And I am going to switch this cable over to the other side so that this IC is being powered by the same circuit that it's controlling. So the purpose of this is to demonstrate that in a normal real-world scenario where you're powering this off of the actual circuit itself, even when you have the IC being powered by not the mains power, but something which may or may not be available, in that moment of the switchover, the IC is still powered enough to come back online and continue working when the power switch moves. Okay, same thing there. See that? The light on the IC didn't even go out. It still continues running, no errors, no problem, no nothing. And we have successfully switched over to the mains power because our secondary power generation storage ran too low. Alright, so let me plug this RTG back in so that we have a consistent power supply. Our circuit has automatically switched over to use it. And now we are going to try something else. We're going to try putting a full load on the system. So let me try switching this cable back to the RTG so that this guy won't disconnect or stop working once we fully saturate the cable with 5 kilowatts. Now, I am going to turn on this station battery, which is going to suck power very fast at our maximum rate of 5 kilowatts. Now, what I want to demonstrate with this test is that there will never be a tick where power is flowing from both this circuit, the secondary circuit, and our mains circuit. Because if that scenario were happening, then we would see a cable fry immediately. And we don't want our cables frying. You don't want to set this up on some critical system, walk away, and then at some unknown time, your load ends up exceeding 5 kilowatts. And so at the moment of the flip over, stuff blows up. We don't want that happening. So let's demonstrate that. We see we already have a decent amount of charge on our secondary source. I'm just going to flip on this load station battery. You can see that these things turn off. You can see that our actual is 5 kilowatts. Our potential is 5 kilowatts. As power rapidly transfers from our secondary battery to our load battery, you are going to see a moment where this switchover happens and no cables are going to fry. Boom. Switchover happened. No cables fried. Our actual never exceeded 5 kilowatts, so both transformers were never supplying power at the same time, which means I have just demonstrated that this system is both cable safe, safe to use in actual environments, even to power sensitive 100% uptime systems, and I like to think that this is a really cool method of alternative power generation. Now, I'm going to be making this script available on the workshop. It's really simple, but I will eventually be making other iterations on it that hopefully are a little bit smarter, handle more edge cases, etc., and maybe even can supply the reverse scenario where you have, instead of a primary battery, switching to a mains occasionally, where you instead read from the mains charge and only use the battery backup when the mains disconnects. But for now, there's a few things you need to know about this setup. Okay, firstly, where are you going to be using this? Well, anywhere where you're generating power inconsistently. You can't always trust that that power is going to be available because the generation fluctuates, so you always want to be able to access your mains power, but whenever you generate power over where you are, you'd like to use it. Now, the cost of this system is just the 50 watts to run the integrated circuit housing. So that's going to be just fine if you are generating a lot of power. If you're generating barely any power, that 50 watts is actually just saving you the cost of the wire to run all the way back to your mains power input. Now, the last thing to be aware of is that I am running the data line on a different circuit than I am running the power line. The reason for that is, if I ran this power line on the circuit that the IC is reading from, it would defeat the point of the entire circuit because I would be feeding this power in constantly. However, by separating the data onto its own cable, I'm able to access the charge level from the IC without actually injecting any of the power from the battery into the circuit. That's really the only quirk of setup. Everything else is pretty straightforward. We're able to read and control the transformer from the output side, so that's no problem. And we are able to access the battery off of this data port, and that's no problem. And that's all you need to make this circuit functional. So there you have it. Auto-switching secondary power generation that'll allow you to distribute your power generators across your base and use them to power different subsections of your base or rooms without having to worry about the inconsistency of power actually shutting things off. This took a good amount of setup, thinking, design, testing, and video recording, so If you appreciated the content and the results of the test, I would appreciate it if you drop me a like, maybe consider subscribing for more Stationeers content, and happy engineering, everyone!